Hello everyone, welcome to the chemistry class. Let's start IGCSE chemistry from the topic 1, and the topic is about the states of matter. States of matter. So this is going to be kind of like an introductory topic. Okay, I just want to test it out to check everything. Okay, and hopefully I would be making a series of very short videos, maybe some larger lecture as well, about chemistry and biology overall for the IGCSE O levels. Right, so let's start with the states of matter. First of all, what you need to know, and hopefully everyone already knows, is what is matter. Okay, so if you want to define it, the simplest definition is anything that has mass and occupies space. All right, occupies space means it has some volume, is considered matter. Now if you look at your cell phones, your laptop, your mobile phone, if you hold them or try to feel them, they would have some mass, and if you put them somewhere, they would occupy some space. Even the air around you, if you turn on the fan, or if you are driving or riding a bike, okay, so the air would, you would easily feel the air, right? And you can easily tell that it does have mass and it does occupy some space. All right, any kind of gas in the cylinders, they occupy some space and they do have mass. So all of that is matter. Now if you have paid attention, all right, there are three major states of matter. I hope you already know what those states are, right? So let's make a very short table here. Okay, so we can put it here. So the three states of matter, as we already know, are: number one, solids, number two, liquids, and number three, gases. Right, so you already know about that. Okay, now we're going to see their properties. Right, the properties I like about, the properties that can easily help you to distinguish between these three states is: number one, shape or form. Okay, you can say shape or form. So solids, they always have a definite shape. Okay, they have a very defined shape or form, just like your cell phone, your laptop, yourself, clothing, all of these are solids. Right, liquids don't have a definite shape. Okay, no defined shape. Okay, for example, let's talk about water. If you put it in a glass, it would take the shape of the glass. If you put it in a bottle, it would take the shape of the bottle, and like wherever you put it inside, it would take its shape. Right, so it doesn't have a defined shape. Same thing is with gases. Okay, no definite shape. All right, they acquire the shape of the container. Number two, volume. So solids always have a definite volume, a defined volume. Right, liquids also have a definite volume. All right, but gases do not have a definite volume, right? Why? Because if you put pressure on them, their volume can change easily. All right, so anything, if you see, that has you can say that has definite shape and volume is solid. Anything that doesn't have a definite shape but um, the volume is defined, right, that's a liquid. And any kind of substance without a shape and defined volume, you can say it's gas, right? There are a bunch of other properties as well. Let's talk about that, right? Space between particles, space between particles. Those particles could be anything, okay? It could be atoms, molecules, ions, right? So solids, the space between particles of solid is very little, okay? Little space, okay? Liquids have slightly more space, okay? And gas molecules, or even it could be, if these are noble gases, it could be atoms, right? They have large spaces. Now, next property could be the forces of attraction. Keep that in mind. That these two properties are extremely important. Forces of attraction between the particles. So solids, their particles are very close to each other, so they have very strong forces of attraction. Liquids, they have, you can say, intermediate, slightly less than the forces of attraction in the solids, intermediate. And then let's talk about gases. They have weak intermolecular forces, right? Or weak van der Waals forces, you can call them. Then another property is surface boundary, okay? Surface boundary. Solids do have a definite boundary, okay? But if we look at the liquids, they also have a kind of like definite or defined surface boundary. You can put some water or alcohol or any kind of drink, soft drink, in a glass of water, and at the surface it would have a defined boundary. At least you can identify that boundary, okay? Gases don't have a defined boundary, okay? So these are some of the properties of solids, liquids, and gases. Now let's talk about how these states can easily change, right? We call them physical states of matter, okay? Let's talk about change of states, physical states of matter, okay? So let's talk about, let's say this is solid, right? This is a solid, right? In case of solid, the particles are very close to each other, right? They are very close to each other. Let's say these are the particles making up the solid, right? They have very little space in between them, okay? So but these particles, they are not sitting still, right? These particles are vibrating at their position, slightly vibrating, but they are vibrating, okay? Vibrating. These could be ions, atoms, molecules, okay? Now then we have liquids, right? Now these particles are moving here and there, okay? So let's say these particles are moving randomly. Let's say this is a beaker, okay, and those particles are moving randomly here and there, okay, and they are also vibrating, but they are moving freely from one place to another place, okay. Then we have gases. The movement in liquid particles is slow, but in case of gases, the particles are moving freely, okay, here, there, anywhere. They are moving freely, randomly, without any particular direction, right? So we can change one state of matter into another, okay. If you change solid into liquid, that process is called melting. All right, and if you change liquid into gases, that process is called boiling. In the reverse direction, right, in the reverse direction, if you change gas into liquid, this process is called condensation. And if you change liquid into solid, right, that process would be called freezing, usually. All right, now let's talk in terms of energy, okay. I mentioned here forces of attraction and the energy, right. Now if you remember, in the solid, forces of attraction are very strong attraction. So molecules or particles are very close to each other. They have they have very strong attraction, but they have very less energy. In terms of liquid, they have slightly weaker attraction, but more energy. That's why they are able to move here and there freely, okay. Although they are moving very slowly, but they are moving freely. They are not sitting at one point and vibrating just like solids. They are moving in liquid, so they have more energy. In terms of gases, they have much weaker attraction, right, and they have very high energy. That's why they are randomly moving here and there with high speed, right. So if you look at these 2 points right here, okay, now what do we need to do, right? What do we need to do if we want to change solid into liquid? What do we need to do? We need to increase the energy of particles so that they start moving freely. And how do we increase the energy of particles? We provide them energy, and the easiest way to provide energy is by heating. If you heat a solid, the energy of the particles would increase, the attraction would decrease, and the state would change from solid to liquid. Same thing goes from here. If you keep heating, the attraction would further decrease and the energy would keep rising, and the liquid would change into gas. This is how you can easily change one state into another state. Okay. uh, Now like melting point, when you heat a solid and its particles start moving a little bit freely, we would say that is the melting, and the temperature at which the solid would melt would be called melting point. Okay, let me write it here. Melting point, right, is basically the temperature, I'm just writing temp, at which solid melts. Okay, it's basically the temperature at which the particles start moving freely. Okay, and then there is boiling point. Its simplest definition is boiling point. Its simplest definition is the temperature at which liquid boils, and when the liquid start boiling, okay, boils and evaporate rapidly, right? Although evaporation is taking place all the time, but the boiling, at the boiling point, evaporation is very rapid. Okay, so that was a little bit about the states of matter and how you can easily change them, and what's the major difference between the different states of matter. Okay, next we would go into the heating and cooling curves, how we can differentiate between these states by looking at the cooling or heating curves. We will draw a graph, and that graph would show at which temperature the liquid is boiling, at which temperature the solid is melting, and all that. Okay, if you have any questions, you can write them down in the comment section. I'm just trying to make these videos, just started it. Let's see how it goes, and if you guys need any personal tutoring help, you can write down in the comment section. I can share the email with you. You can send me an email and we can communicate. Thank you so much and take care.